So the logical reasoning behind AI is a huge set of data that runs, and there's a lot of demand for data science teams to make sure that our AI models are running correctly and accurately. And that's why I just came up with this topic of sprint to insight, bringing agility to data science. Okay, I wanted to just start with a quick note here. I will ask everyone here, you all have been using data science in some form or the other. It doesn't have to be complex lines of codes or models, but you all have been using data science for your personal and financial decisions or whatever decisions you take in your life. So I'm just saying that data science is not only about lines of code or models building or anything, it's about making sure that you're building good inference results to make sure that the decisions you take are valid. Next slide, please. Okay, go to the next slide. Okay. So this is some examples of data science, just for to set you the context, right? What exactly happens in data science? So again, just go to the simple thing, right? You go to a market, you decide there are some specific days of the week where the cost of the goods are really cheap, and you try to make a larger purchase. That's data science in action. You are making sure you are making some benefiting decisions based on the data by using patterns to save money. Can you go to the next slide, please? This is Lagos, right? I mean, how's the traffic here? I mean, I don't have to say anything. So this is just a quick example, right? I mean, if you're in Lagos, Bangalore, Mumbai, the top cities where they're exactly crowded, you want to go to a place where there's less traffic, and you always try to have some alternate routes in mind to reach your destination on time. So this is a transport example, is the best example. If you see a lot of traffic on your road, you don't want to go into that road, right? You take an alternate route, which is faster and more efficient. That's data science in action. Next slide, please. Simple things, very common, very important. That sometimes you're cooking something or experimenting as an amateur chef at your place. You might not know what exactly you need to put in terms of the quantity of salt. So sometimes the dish might turn too salty, or sometimes the dish might be less salty, right? So you are learning from experiences. That's again data science in the real life. Okay. Again, I really want to illustrate the fact that data science is always not about building models or writing complex lines of code. It's about the three key things here: observing, learning, and improving, right? So I will be explaining you all these 4 steps here, taking a simple coffee shop example as how we gather beautiful insights. But at the heart of data science, we are actually doing these 4 things: observing, gathering data, learning how to make better inferences, improving what we can do better next time to ensure our decisions are better, and making sure, the last but not the least, making sure that we are maintaining a straightforward and a simple process. Okay. This is a very open-ended question, right? How many of you have changed something because it didn't work before? Anyone?
Sorry, I just raised my hand. I didn't know the mic was coming to me. Okay, so for me, honestly, if I work in a particular sprint and I get frustrated by a situation, circumstance, when we do our retrospective, I ensure that we talk about it so that I don't repeat the same thing in the next sprint, because God knows I don't want to be frustrated again. So I more or less learn from the mistakes I made and then change that so that I don't repeat that in the next sprint. That's it.
Thank you for the answer. Again, what you just mentioned was that you are using your past experiences to make sure that you are gaining better results next time. That's again data science in action. Again, I just explained you about this, but again, putting it one more time, as teams are growing, as AI models are maturing, it's not always about writing lines of code or analyzing complex algorithms. It's about making smarter decisions every day. So if you look at Netflix, YouTube, right? I mean, all these nicest software companies are building recommendations engines based on your viewing history and what are the type of programs you watch, right? Again, it's about suppose if you're a sports freak or a sports fan, you try to watch a lot of sports, then you find a lot of sports videos that comes to your Netflix recommendations and YouTube recommendations. If you're a music fan, jazz, Afrobeats, you will have a lot of artists that follow these things. Your next movie is part of a data science thing. They are gathering data sets based on what are your viewing habits, and based on that, they are suggesting you some of the best movies you can watch. Flight on time, the air traffic control uses data science to optimize the routes. And finding the right job candidate, LinkedIn uses a lot of artificial intelligence and data science to make the perfect match. This is a simple example I would like to illustrate for the coffee shop example. How to improve coffee shop sales? Let's do a quick experiment here. Okay. So I guess most of you have been to coffee shops, right? I think usually it's very busier during the beginning of the day. Then gradually the crowd becomes less during the afternoon. And in the evening, it might again have an increased amount of people coming to the coffee shops. So do you know what exactly happens at Starbucks or some of the leading coffee shop companies, how they actually monitor the staffing levels, right? So a coffee shop wants to know what time of the day they sell the most coffee so they can plan the staffing better. So the first steps is always involves in collecting the data, right? So from the point of sale software, every time a coffee was sold and how many was sold, the data is recorded in terms of collecting data. The next steps is involving around when the maximum amount of sales happen. For example, morning has some of the highest sales, afternoon slower, and evenings it might gradually taper down. And step 3 is using this insight to schedule the staffings at the coffee shops. But again, a quick caveat here, right? Imagine Starbucks has come to you to provide recommendations on the staffing levels at a company, but they don't take any action, right? So that means that you have given the inferences on the data science perspective, but they have not used your models. So the shop saves money by optimizing staffing and increasing scales with targeting promotions. But what exactly is happening is you're finding patterns in data to make them smart decisions. One sec, please. Again, this is just a quick rundown of some of the technicalities here. So the step 1 data collection involves the timestamp at what specific time the coffee shop sales was made and the number of quantity. It also depends on the data like day of the week, weather, and promotions. So any data science projects, this is a very important step, the data cleaning and preparation. So as we are converting raw data to a more structured data, we need to ensure that some of the fields and some of the patterns are taken into consideration. So data cleaning and preparation is very important for any data science project to be successful. This is a very important step. And the third the most important part is exploratory data analysis, right? Because what is data science? You're building patterns to analyze those features. So you're creating time series slots, you're building heat maps, you're identifying the sales peaks. As I mentioned, morning and afternoon usually have the highest amount of coffee sales activity, and you're also discovering some hidden patterns. So this is one important thing in data science project, right? What is predictive and prescriptive analytics? So predictive analytics is some simple thing, right? Based on your coffee shop sales, how many coffees can be sold day after tomorrow or the week after? That's predictive analytics. But what is prescriptive analytics? Based on the predictive analytics, we adjust the staffing levels, we adjust the quantity of the inventory, those things. Those things are called as prescriptive analytics. For any data science project to be successful, we need both the predictive and prescriptive analytics to be as close and as mature as possible. And the last and the most important thing is deployment and actionable insights to ensure that things are working as planned. So as you know that it is a very sequential process here. So the first step is involving data acquisition. The second step is data cleaning, data validation, exploratory data analysis, modeling insights, and decision-making action. So let me ask you, by just looking at this clean columns, what frameworks do you feel it like? What frameworks we can use in data science to ensure that these things can be done in a more systematic way? Is it SAFe? Is it Scrum? Is it Kanban? Any thoughts? Okay, we'll explore it later. Yeah, I just have an open question here. Based on experience in data science projects, which agile framework do you think works best for data science? Yeah. So Kanban framework is one of the most suited frameworks for doing sprint in data science. You can go to the next slide. Next one. Yep. Yep. This is the most important, I would say this is the heart of the bringing agility to data science. This is the most important thing because we need to first define the problem, right? Because the most common aspects when you're working with the data science projects team is that the business analyst and the data analyst, they have to work together. I have seen in many companies personally that business analysts and data analysts, they don't work together because they work in silos, which will create the problem. So the most important thing is you should understand what problem is your data science model going to solve. And that's by asking the right questions and defining the problem more accurately. The next one is, as I explained in the Starbucks example, gather and prepare the data sets. It's very important because you're collecting the insights from your customer. Then you're generating insights based on the heat maps. What time of the day the coffee shop sales were higher? What time of the day the coffee shop sales were lower? And how many coffee shops were sold, coffee sales were made in the evening? So you're generating insights. Then you use linear regression as few of the models to test those models, and finally you're deploying the solution so that you can adjust the staffing levels. So this is a data science end-to-end project flow using the Kanban framework of asking, defining the problem, gathering the data sets, generating insights, testing the models, and deploying the solution. So this is typically what, from my experience working with a lot of data science teams, this is how typically a structured backlog would look like from a data science perspective. So again, you are building backlog from a Scrum perspective, which is, again, if you're developing some software application, that's a good practice. But if you're entirely building a data science application where you're focused on building the models and generating insights, this is the best approach. So from a backlog, you understand like where is your data set coming, what are some of the things that you need to do there. Then the second step, as I already mentioned, is about cleaning the data sets, right? So making sure that your duplicates are removed, the variables are standardized and normalized. Then you do a peer review on the data quality report, identify relationships and modeling things, and then you finally review and generate the reports. In spite of all these things, right, Gartner, a premier research institution, has suggested that why 80% of data science projects fail. Anyone want to talk about why some of the data science experience projects failed? And the last and the most important thing is, data science is not like typical software development. It's about discovering, experimentation, and constant learning. So these are some of the common project pitfalls where you develop some fancy dashboards, prediction without purpose, over-engineer recommendations, and data collection rabbit hole that just goes forever. This is a very typical example, like why is a data availability delays, why our sprints fail. Because sometimes we are always waiting for the data. A data engineering team is waiting for external vendors to clean the data, and some sprints fail because they're always worrying about the data models. Yeah, research-driven uncertainty. Yeah, go ahead. Next slide, please. Yep. Waiting for experimentation, as I said, long training times, repetitive stand-ups, and misprint goals, which is very common in data science project, because they are worrying about perfecting a model rather than delivering inferences. So just like how we have sprint goals, right? This is a specific things for team goals for data science. As I said, data science is not incremental in nature, right? I mean, there's a lot of inferences, there's a lot of experimentation, and there's a lot of outcomes and learning that's important. So one of the most important team goals, just like how sprint goals for the Scrum teams are, is that you need to understand what are the predictable outcomes you can make, what are some of the measurable impacts that your model can make, how you can support through the model transparency, explain the logical reasoning behind why you are building that model, and you should be ensuring that your supporting environment means that the data quality, the data governance, those things are taken into consideration. And this happened in one of my companies that I worked for 3-4 days. We just had this same status. The model is in training, and we are just training the model. No blockers, and no dashboards or no outcome. This is just a quick example why data science projects are very different. Okay. Yep. I think this is the most important thing. Imagine like you have two data science teams. One team builds the Imagine you have two teams. One team builds the perfect model, months of work, incredible accuracy. No one uses it. This is really bad. Another team shares insights every week, tests small ideas, incrementally adapts quickly. Their model isn't perfect, but their impact is real. So I would always recommend teams to share insights, test small ideas, and adapt quickly to ensure that model is in the continuous improvement stage, where your model doesn't have to be perfect, but you're providing some impact to your stakeholders. Yep. So in data science, perfection doesn't win, progress does. As long as you're able to successfully evaluate progress, you are able to ensure that your data science models are built right. So just a quick recap here. The journey from rigid to be flexible. So Agile works for software, but breaks down differently for data science, because discovery is not feature delivery, right? Data science is all about discovery and doing the models. It's not you're developing some software and providing some features to your customers, right? You're always experimenting with timelines and unpredictable experiments. So make sure that your experiments have some sort of a end by having some sort of a logical reasoning that why you're running those experiments and models to ensure that it's being successful. As I mentioned, Kanban and experiment-based planning will give teams some flexibility focused on learning, flows, and validation. So just like how we have successful Agile teams, the recipe for high-impact data science teams is establish good teams, healthy backlogs, and stakeholder alignment. What I mean is that data analysts and business analysts should work together, have a clear hypothesis, logical reasoning, and the purpose and the alignment behind the models you are creating in data science, and ensure that you're rapidly providing feedback to your stakeholders to ensure that there are demos and short feedback loops to ensure that your efforts are not wasted there. So what does the future of data science looks like, right? We move to rapid experimentation cycles. So the key thing about data science teams are we should experiment fast and fail often, right? If we can't experiment, don't commit to the stakeholders early. Experimentation is the key here. Why I am doing this model? Why am I building this model? What is the inferences I can save it to my company? What is the cost benefit analysis I can provide to my company? So experimentation provides the logical reasoning why you're building that model. Validate your assumptions. So as long as you're building a model, ensure that your assumptions are clearly documented. And when you're delivering a model, make sure that you give a context and an appropriate reasoning how your model would be successful in the long run. So this is some blueprint for data science teams. Replace sequential waterfall with rapid hypothesis testing cycles, right? So basically what does it mean is try to test on your models and data sets every 2 weeks with experimentation goals. Make sure that data scientists, engineers, and business analysts work in collaboration to ensure that they are coming with the right approach and right product, right model, and make sure that you are prioritizing features based on the impact and the benefit to your stakeholders rather than technical interest. Just like any Scrum teams, the data science ceremonies involve sprints planning, daily stand-up, sprint review, and retrospectives. Yeah, this is something like, as you mentioned, right? Some of the common pitfalls is that teams abandon all planning in the name of being agile. So what we should focus on tactical execution, strategic roadmaps here. Talk to your stakeholders about what is the amount of production-ready models you are deploying every sprint, and make sure that when you're defining your Scrum ceremonies, make sure that you're understanding the context and the problem and the solution at every level. I would just like to explain this. Agile data science adapts to uncertainty rather than fighting it. Embrace the experimental nature of data workflow by structuring projects to accommodate discovery and pivots, right? So as long as you're experimenting with data and as long as you're building models with logical reasoning, this is very important here. Keep communicating to your stakeholders on a daily basis. Why am I building the model? What is the logical reasoning behind the model? And how I can make the model better. Start small and expand, right? So begin with a small pilot project, customize your practices, and ensure the unique needs are met. The most important thing is it's not for output, it's optimized for learning, right? So as long as you're building models, you are trying to learn for those things, ensuring that you are learning from your feedback loops and ensuring that things are going in the proper way. Yep. Thank you.
Thank you very much. Please, another round of applause for Ganesh. I think we can take one question. Do we have one question for Ganesh? Any question? Okay, we have one person on that side.
In the context of agility and Scrum, when we want to begin our sprint or want to do anything, we always have to have the definition of done. So now that there will always be a lot of analysis back and forth and all that, how are we able to translate that into definition of done so that we know that by this point in time when this old data is, then this sprint is done or this activity is done? How do we reconcile that?
It's a great question, right? So great question. Thanks for asking this. So one of the most important things in data science teams, right? Again, we are not trying to define the outcome in a very structured way or in a very foolproof way, right? So I would say that let I make the definition of done for a simple story or a feature would be make sure that my model is 50% better than my previous model, right? I'm just giving an example, right? So when you're defining in terms of tangibles, like 50% better than my previous model, means what exactly you're doing it. You are trying to have a more ideal data set. You are trying to have a more data cleanup, and you're using linear regression and few other modeling techniques to ensure that the modeling is going in the best possible way for predictive and prescriptive analytics. So again, you don't have to have measured outcomes in terms of tangible outputs, but ensuring that your model is consistently performing right, answerable to your stakeholders, and you driving some great business decisions and business benefits using this model for cost savings is a great idea as a definition of done.